The polygons are similar, find x. Now, this is what we have here, and it's not as obvious as what we have. In previous problems, we're so used to seeing something that looks like this and something that looks like this, and then you match things up crisscross applesauce. That's not what we have here, except it kind of is. I have that triangle living inside of this triangle right there. And if I wanted to, I could rip this apart and write down as much information as I need based off of what I just did. That red triangle was 36 right here, 27 right there, and -4 plus 4x right there. That big triangle was 64 all the way across. And if you're like, what about that part? I don't care about that part. It was 72 and 96. And now what I have is two separate triangles. That used to be one big triangle with a little triangle inside of it. Now, whenever I'm finding similar triangles or missing side of similar triangles, I like to compare the big to the small and make a proportion. We have extra unnecessary information. First off, I definitely have to find x. So I'm going to make sure if I'm going to compare the big over the small that I first start out by comparing 64 over -4 plus 4x. Definitely have to do that first. Now, if you're wondering, all right, so what other sides do I do? It doesn't really matter. I could do 96 over 36 or 72 over 27. It doesn't matter. So I'll do 96 over 36 because it doesn't matter at all. Now I have a proportion, and whenever you have a proportion, you do crisscross applesauce. So we are going to multiply -4 plus 4x times 96. And when you do that, you have to make sure you set up a distributive property problem because this is two separate things being added together. -4 plus 4x. Then you have an equal sign, and you multiply these two numbers together. 64 times 36 is 2,304. I did that in my mind. Now I distribute. 96 times -4 is going to be 384, -384, plus 384x equals 2,304. If I add 384 to both sides, that gets me 384x equals 2,688. Divide both sides by 384, and I think it's 8, but let me go off to the side here and double check. Glad I did, because it's actually 7. Whew. But that's how you do it. A triangle within a triangle, just view it as two separate triangles. Rip it apart if you have to, which I did, and you're good to go.